Hello everyone, welcome to Applications Manager's free training series on application performance monitoring. Now let's quickly jump into today's agenda. Here we are going to cover a overall of 4 parts, and in the first part we will discuss and understand the application performance with APDEX scores. In the second part we will explore how you can monitor code flows through applications via distributed tracing. In the third part, we will looking at how you can directly pinpoint to the problematic elements in your application code. At last, we will visualize the dependencies in your application's architecture with the help of automated service map feature. Now, before discussing the topics in the agenda, let's start why let's start with why application monitoring nowadays. Now, just imagine a user who is accessing an e-commerce website. So let's assume you are an e-commerce website owner, and in that way, so let's say your user is accessing your e-commerce website and trying to purchase from your store, from your online store. Now, after adding the required items to the cart, they are trying to place the order. Now, at the time of placing the order on the payment portal page, they encounter some issues like the portal is taking more time to load, or it is getting into a blank page, or it is throwing some 404 error codes. Now, this kind of operation could result in potential customers being unable to access your application. So what happens if a potential customer is trying to buy a product from your online store and suddenly this happens, which will definitely leads to a loss of business. And additionally, at the backend, developers who are working with your web application may struggle to identify the root cause of this issue. As the demand for the application has increased, the complexity of its development has also been grown. So therefore, it is essential for developers to ensure that the website is bug-free, handling database load efficiently in order to provide better services to the users. So to make it happen, observability is necessary here. Now, here are some of the contemporary trends in application monitoring. Let's discuss one by one. Fine. The first trend is cloud native applications. So many large enterprises are moving their applications to the cloud. These applications uses the microservices called the Docker and Kubernetes, which used to scale them, makes them flexible and make them more efficient. Now developers and the operation teams follow DevOps practices to deliver software faster. So monitoring is important here to track each component and ensure the application can handle large number of users. And the second trend is the use of artificial intelligence for IT operation, which is the AIOps, and machine learning, which can be also help to detect the unusual system behaviors, automating the IT tasks, predict future issues using historical data, and optimize resources based on the real-time performance on your application. The third trend is the user-centric monitoring. This approach focuses on the end-to-end experience by tracking the user's journey from accessing the application to completing the tasks. So it measures the page load time, response time, and overall responsiveness to improve the user satisfaction. The fourth trend is going to be the application observability. So here it provides a deep insight into your application performance and health by analyzing the logs, traces, execution time, and transactions. So this specific thing helps to identify errors, bottlenecks, and inefficiencies in the code. The final trend is full stack performance monitoring. So it monitors the entire application stack from the front-end interface to the back-end servers, including the databases. So real-time data such as response time and error rates are used to detect and fix performance issues quickly. Now, by adopting these modern trends, organizations can monitor their application in real time, identify issues early, and ensure better reliability, availability, and user experience. Now here, The traditional applications. So if we can able to discuss the benefits of the modern versus the traditional approach in the application side. So the traditional applications were usually hosted on a on-premise servers or in a single data center. So this often cause high downtime, limited availability, and performance issues during peak traffic, or scaling peak traffic time. And also scaling is required purchasing if you are going to purchase a new hardware, which involved high cost and long setup time. And maintenance was also expensive because physical infrastructure needed regular updates and repairs. Now, on the other hand, modern applications use cloud computing and containerization to improve availability and reliability. Now, features like load balancing, redundancy, automatic failover, and global distribution help to reduce the downtime and ensure smooth user experience. And cloud platforms allow you to flexibly scale based on the demand and requirement. So, which also can reduce upfront costs and improve the resource utilization through automations as well. So in traditional systems, content delivery was limited to specific locations, which caused the latency for users in other regions as well. Now, modern solutions use content delivery networks and edge computing to distribute content globally. So this reduces response time and provides faster, more consistent performance for users worldwide. So operational efficiency also can be low in traditional approaches because deployment, scaling, and maintenance were done manually. In the other hand, modern DevOps practices such as CI/CD, infrastructure, and container orchestration automate these processes. And microservices architecture also improves the flexibility, which allowing you to update without any downtime. Overall, modern application development offers better availability, lower cost, faster global delivery, and improved efficiency compared to the other traditional methods. These benefits help businesses stay competitive and responsive to the changing demands in their organizations. So as we discussed about the modern and traditional approach, now let's see what are all the factors that are affecting the server application performance. So if we look at here, several key factors play an important role in determining the performance of an application. The first factor is response time. When a user performs a transaction in the web application, the request travels through a network and application layers to reach the server, and the response is then sent back to the user. So response time here refers to the total time taken from sending the request to receiving the final result. And also, database query response time is also critical as slow queries can significantly reduce the overall performance of your application response time. So here, application response time includes processing delays, network latency, and system load as well. Another important factor in application code, bugs, inefficient logic, on excessive exception handling can exception handlings can cause unexpected behavior and performance degradation. So frequent errors often indicate deeper issues in the code. Stack traces helps identify the sequence of function calls that led to an error. So which making it easier to locate the performance problems. And the third one is the memory usage. So memory usage is very also crucial, and high memory consumption can slow down the application or even cause crashes. So a memory leaks occurs when an application do not release the unused memory properly, which may lead to increasing memory usage over time and reduce the system stability. And finally, database plays a major role in the performance. Slow queries and too many database calls can affect application responsiveness, and optimizing these queries can reducing unnecessary database interactions and greatly improve speed. In conclusion, monitoring response time, code efficiency, memory usage, and database performance is essential for maintaining a smooth and reliable application. So regular performance testing and tuning helps this to ensure consistent and efficient operation in your application delivery. Let's see the application performance monitoring APM Insight. So about the functioning of it. And here in App Manager, the APM Insight is going to be an add-on feature that uses an agent for monitoring the application. The initial setup will involve deploying the agent onto the servers where the applications are running. These agents are responsible for gathering the performance data and transmitting it to the application manager for analysis. The agent within the application server utilizes the method bytecode instrumentation to track the individual user transactions as they navigate through the application stack. Then it will send this transaction data to the applications manager as if at a fixed time interval. And this approach will enable detailed monitoring of the transaction performance, facilitating the identification of the bottlenecks or any other performance issues occurs. The tool will offer code level visibility, allowing monitoring of base performance by capturing the real-time user interaction with the application. So users can configure any alerts and notifications based on the predefined thresholds for the metrics that impact their application performance. As I mentioned, when the application performance reaches this threshold, the tool will send an alert to the IT team. So this alert system will help the developers and the IT team to pinpoint the areas that require improvement in the performance, such as application code, database related issues, or the page load times, and etc. So this proactive approach helps address the issues promptly and minimize the downtime on your application. Now in this slide, we can see some of the key performance indicators. So these are some of the key performance indicators in the APM Insight feature. The first one is the APDEX score. So APDEX score is a numerical measure of user satisfaction with the performance of the application's response time. The second one is the response time. So it measures the average time taken for the application to respond a user request for the transaction across the application usage. So lowering the response time is generally more desirable. And the third one is the request. So which is a total number of requests made to the application within the specific time frame and helps to decide the overall workload and usage of the applications. The fourth one is the data throughput. The data throughput indicates the amount of the data in bytes transferred or processed in and out of your network request. So by the application, whenever there is a data throughput request that has happened by the application during the monitoring period, so which will eventually the application's data handling capability as well. So the fifth one is the exceptions. So it will track the number of exception errors or the failures that occurs during the cycle of transactions in a chosen duration of the processing rate. So these exceptions could be various types of errors such as server errors, timeouts, or other issues that affects the application's normal operation. So by using these types of critical indicators, which is a key performance metrics, we can quickly able to analyze the performance of our applications. And so far we discussed why application performance monitoring is necessary and how it works in the APM Insight agent and how the technology nowadays treats this observability as an important area. And now we can achieve this monitoring in Applications Manager as mentioned with the help of APM Insight feature. So this APM Insight feature will give you an understanding of the way how your application is behaving for your end users who are accessing it by a end-to-end transaction monitoring. So by basically with the help of this agent-based monitoring, you can be able to understand and analyze the complete user performance of your application. And the supported technologies in APM Insight are Java, .NET Core, Node.js, Ruby Rails, Python, or PHP. So if your application is built in any of these platforms, you can very well able to bring it into the monitoring of App Manager. So now let's understand the application performance with the help of APDEX scores. The APDEX score is categorized based on the application responsiveness. The first one is the satisfaction. So this category represents the highest level of user experience, where the application's response time is between the satisfied threshold and the excellent threshold. The users in this category are generally satisfied with the application performance. The second one is tolerance. Obviously, the tolerance category indicates that the application time between the tolerating threshold and the satisfied threshold. So users in this category might tolerate the performance, but may not be entirely satisfied as under the satisfied category users. One is so this category represents the lowest level of user experience where the application's response time is below the tolerating threshold. So users in this category are more likely to be frustrated with the application performance as it does not meet their expectations. So this application performance index or the APDEX score is a standardized metric that is used to measure the user satisfaction and the application response time. The APDEX scale ranges from 0 to 1, where 1 being the best score and representing excellent user satisfaction. So based on the total samples that are collected, the APDEX score is calculated as the sum of the satisfied plus half of the tolerating count. Overall the total samples that are collected during the transaction period. So now monitoring application performance using APDEX score provides several important advantages. The first one, it offers a user-centric way to measure performance by showcasing how your application behavior directly affects the user experience. So this helps teams to understand which areas need important to increase their user satisfaction. Second, AppDex score simplifies complex performance data into a single, easy to understand metric. So this standard measurement makes it easier to assess application performance without analyzing amount of technical data. Third, AppDex score allows organizations to benchmark and compare the performance of different applications. So this helps identifying high performing systems and encourages consistent performance of the environment. Fourth, AppDex score supports proactive issues and proactive issue identification and code optimization as well. When performance drops below at the acceptable levels, low AppDex scores highlight critical transactions that need attention. Alerts helps teams to quickly detect the issues and focus on improving the key areas that impacts the users. Finally, historical AppDex trend data, which helps you to analyze the performance patterns over time. This makes it easier to track improvements, identifying recurring issues, and maintain a consistently positive user experience. And as we discussed about the advantages of the AppDex score, and further, all the transactions would be captured in the product, and among which you can select the key transactions and monitor them individually, which will also help you to refine the key business transactions. And we do how by further we have introduced the transaction threshold support by marking the important key businesses transaction. So administrators can now configure thresholds and alarms as well. And further, you can view the health status of the alarms, perform the root cause analysis, and track performance metrics, which will eventually ensuring the most critical application parts receives timely attention and actionable insights. So basically, so whatever the transactions that are we are going to refine using the key transaction, and now you can create a custom threshold to monitor those specific transactions over here. Now let's see how you can monitor the code flows across your applications via distributed tracing. So in microservices architecture, so let's take the microservice architecture. So it is necessary to monitor the transactions made between two or more applications or services. So with the distributed tracing feature, you can now track the transactions made between two or more applications seamlessly. And distributed tracing tracks how a request flows across your multiple applications when an application makes an API request to another application. Here, APM Insight adds a HTTP header containing tracking the metadata. If the APM Insight is enabled in receiving the application, it reads the header and returns the tracking information in the header response. If that application calls another service, the same header is passed along, allowing the entire request path to be traced across the distributed system. So using this data, teams can monitor when the transaction started, how long it took to respond, and which application and transactions were involved. So by expanding the application view in the interface, developers can see the detailed method calls and code blocks that consumed the most time. And this helps to identify slow components, track inter-application calls, and quickly pinpoint to the performance issues. As I talked about the pinpointing the performance issue, now let's see how to pinpoint the problematic elements in your application code. So let us see the need to eliminate the issues in the problematic code. So as you were aware, stack trace represents the movement of an application during the execution of a program. And when the Java application throws an exception, the stack trace gets logged within it. So by enabling the stack trace provided by the APM inside, the developers can pinpoint the exact line of the code and the sequence of the function calls which leading to the specific issue. So if basically we can able to identify the specific code level stack to eliminate the problem. Further here, we have introduced the milestone marker feature. So in APM Insight, which allows you to create, manage, and analyze the performance milestones for your applications. So with the help of this specific feature, you can create milestones to capture and compare application performance data on a specific dates, for example, around key events or releases. So this helps you to evaluate the impact of the recent deployments or configuration changes in your application behavior. To understand this more clearly, I can give you an example. Let's take your application is hosted in a Windows server. So you can set up a milestone like let's say tomorrow is going to be a patching activity is going to be held. So in that case, you can create a milestone before the patching and you can create a milestone after the patching. So with the help of this, you can now compare this data, how it performs before and after the patching. So with the help of milestone, same like the milestone marker. So we have all you can also analyze your application's performance trends effectively by comparing metrics across two chosen dates using the compare view feature in APM Insight. So basically, this feature helps you to identify recurring errors, detect potential bottlenecks, and understand variations in the key performance indicators over time. Which may enable you to make informed decisions to enhance application performance stability and performance at very least time. So here we can go to the last slide. Visualize the dependencies in your application architecture with the help of automated service maps. So what is a service map? The service map will provide you a complete overview of the application infrastructure along with the connections to the other dependent resources. So the main purpose of a service map is to identify the status of the application and its related instances. Also monitor the key metrics like the response time, throughput, and the status of the connection between the application, between the services, and detect and troubleshoot any application problems before the customers are impacted. And also to identify the number of failed request counts, this service map feature can be utilized. So we have the map view, the graph view, and the table view. Three types of views are available to view your service map. So here is the map view. So it will provide a way of analyzing the topological view of your application along with its instances represented in the central node. So your application might be connected to a different services. So in order to make your application up and running, you might depend on different services. So by onboarding your application into the service map, you can able to see the complete health of your dependent services as well. Further, we have introduced the RUM analytics feature in the APM Insight, which will provide you the real-time insights into your user interactions, allowing businesses to monitor and optimize application performance effectively. By tracking the key metrics such as the response time, page views, JavaScript errors, and the geographic performance trends, it helps you to identify slow transactions, errors, and performance bottlenecks across different devices and locations. This data enables organization to proactively optimize your application behavior, ensuring a seamless user experience and improved overall performance. So basically, this real user monitoring, you can in the upcoming sessions, you can have a detailed interaction with this real user monitoring. And I'm just mentioning you that the real user monitoring also can be integrated with this APM inside to have a combined view of the front end and the back end performance monitoring. And also we have the application dashboard in Applications Manager that provides you a comprehensive view of your application performance and user experience by combining the data from the APM inside and real user monitoring. So similar to the a RUM dashboard, this RUM analytics, you can create a separate dashboard and publish this dashboard to your NOC team or your application team. So which also helping the IT teams to monitor the key metrics such as APDEX score, user sessions, failed requests, slow transaction, and error reports. So not only from the front end, from the back end perspective using the APM inside, so you can monitor these metrics from the front end level as well. So with the help of application dashboard, you can monitor combining both the application front end and back end behaviors. Then here we have a auto scaling feature, so which is an automated way of managing the resources of your application. So imagine you have a website or application running on a cloud environment. Whenever the application automatically scales up due to the high user interaction on the site, and to handle the extra traffic, a new instance will be created. That is how the cloud environment or a containerization environment works. However, when these applications are scaled down due to fewer user interactions, user transaction or interactions, this newly added instance will become unused and is still retained. So this will lead to the license being consumed by the unused instances, which may resulting in the new instances not being added for monitoring due to license exit. So hence, in order to overcome this type of behavior with the help of auto scale mode in APM Insight, now you can automatically unmanage or delete the unused instances from your cloud environment. So by enabling this feature, and further adding to the features, next we have revamped the ad monitor page for the APM Insight to simplify the complete onboarding process, making it more reflexive and user friendly. Now, with this structured step-by-step guided flow, you can effortlessly, configure the APM Insight monitoring setup without any complexity. So later, we have the application level alarm metrics feature that allows you to configure alarms using a more granular and set of performance indicators at the application level. So previously, it was in the host level or the instance level, and now we have brought this feature in the complete application level, so you can have the complete visibility over your application performance and configure alarms accordingly. And this enhancement provides a precise monitoring by enabling users to select specific monitor and associate thresholds with the key attributes. So by setting alarms for this application metrics, businesses can proactively track performance deviations, identify potential issues, and optimize application behavior more efficiently. And also in the reporting section, we have introduced the APM Inside application report. So instead of getting your report in an instance perspective, so now you can get the complete report for your complete application in a single report. And added to this feature, we have brought something new in this year. We have introduced the app logs monitoring, so which is a log management capability that enables you to collect, ingest, search, and analyze logs from your applications and servers through a single unified search interface. And logs are collected using the applications manager's FSO agent and are presented in the centralized view, so which will be easier for you to correlate and analyze the log data across your environment. So this requires a agent. So we have the FSO agent, so you need to deploy the agent on your server where your application has been running. Once the agent is deployed, it's the agent duty to collect the logs, and it will be available for monitoring, so you can able to collect, correlate, and understand the root cause, so which is also can be helpful in the following use cases. There are many use cases that we can able to use the log monitoring, so which can be able to identify the root cause, to analyze the compliance and auditing, and for any security and threat detection we can able to analyze the logs, and if there are any performance optimization need to be done from the application level, so with the help of logs we can able to identify the traces efficiently. Now, what is a log type over here? So, as given in the slide, a log type is basically defines the format in which an application writes its logs. So, basically, different applications such as IIS, Apache, and MySQL generate logs in a different formats, right? So, defining these formats as log types helps app logs to correctly phrase the log entries. So group logs from similar applications and enable faster and more accurate searching. So if an application log format is not available by default, you can also create a custom type log to suit your requirement. So where you can add a log type, you can create a custom log and you can add that specific custom log to your requirement. And when it's come to the log types, it includes around 60 plus predefined log types for commonly used platforms across the industry and services. And the custom log types also available, as I mentioned, where you can allow to define the log formats for applications or services that generate logs in non-standard or unique format. As we can see this in this slide, you can able to find the log types had. You can provide a display name. You can provide the custom log type, and you can provide any custom log trace over here, and the retention period and all. So after saving and proceeding to the log profile, you can able to see the complete details. On the left side in the slide, you can see they add log profile. These are all the predefined log profiles that I mentioned. So if your application is hosted in any of these specific log types it's been using, so you can directly use and associate that specific log type for monitoring. Now further, we have a log profile that associates a log type with a specific log sources such as files or directories. So using log profiles, you can efficiently manage log collection across multiple servers and applications. Now let me take you to the Applications Manager UI and showcase a quick demo on the APM Insight monitoring functions. So I hope my screen is visible now. And this is how the Applications Manager user interface looks like. The first one is onboarding a monitor, as I mentioned. So we can get into the monitor, add new monitor. So here in the left side, we have categorized based on the supported technologies, so like APM Insight, application servers, cloud applications, custom monitors, database servers, etc. As we're focusing on the APM Insight, so I'm just choosing the APM Insight. So these are all the platforms that is supported. As I mentioned, this is going to be a add-on feature. So let's say I want to onboard a Java application. I'm clicking on the Java, and this is the revamped guided installation page that we introduced. So here, instead of the manual, still we have the manual steps. So as we suggested to go with this deployment type, which will be easier for you to complete the agent onboarding. So we are going to, the first one is a deployment type. We are going to choose the deployment. So either your application might be available on your specific server or a container. So let's assume it is a host, and we can choose the operating system, the OS. So let's assume it is a Windows, and let's assume it is a Tomcat. So we can find the supported technologies over here. So for every application service on here, we can able to see what are all the application servers for Java that is supported, what are all the frameworks that is supported, what are all the databases, what are all the components and cloud VMs that is supported for your application. So let's assume it is an Apache Tomcat application. So after choosing this, I'm going to next. Now we can name the application as something, and we can choose the port in which it is running. After selecting the Java version, we can go to next. And the next step is going to be the command execution. So you can copy this command and paste it on the PowerShell with the help of the administrator privilege users. And there is a few prerequisites required for that. The first one is connection between the application manager server and the applications should be established, and we require the PowerShell script execution permission for the target server using the below command, so that it will be directly, the agent deployment will be directly completed, and after configuring the Java arguments on your application, the monitor addition will be successful. So this is how you onboard a monitor. This same applies to .NET, .NET Core, Node, .NET and .NET Core as well. And once the onboarding has been completed, so the application will be up and running. I will show you on this demo site. So demo.appmanager.com. So it's a global site. If you want to access it, you can access it anytime. So under the APM tab, we can able to see the onboarded applications over here. So let's assume this is the e-commerce Java application that we have onboarded, and this is how the overview is going to be look like. So here we can sort out the time frame to verify the transactions made between the time frame. You can choose either 30 minutes or 1 hour or 3 hours. So let's assume I want to understand the transactions between the last 30 minutes. So here I can see the APDEX score, response time, request, errors, exception, and throughput, which are the key metrics that we discussed in the presentation. So based on the performance, the transactions that were performed by the end users for the last 30 minutes, we can see the APDEX score. Only 74% of the users were satisfied, 24% users or around 24% of the users are still tolerating the application performance, and 0.5% users were frustrated due to some transaction might be have some high response time or might be crashed, something like that. So we can drill down into this transactions. I will show this later. And the response time, so in the last 30 minutes is going to be 400 milliseconds is the response time, and your application has received around 1435 requests, and in that request, so it's going to be around 350 total errors that was being captured, and around 1527 exception has been captured, and these are all the data throughputs that we that is being captured. So when it's come to the APM Insight, when it's come to the application monitoring, your application might be vast. Okay, so your application might have multiple transactions, hundreds and thousands of transactions that are running on the backend. But we want to make sure, in order to provide a better performance for your application, we want to make sure it has a good response time. So instead of instead of monitoring all the transactions, so here under the top 5 transactions by response time, we can quickly capture the transaction which have the high response time. So in the last 30 minutes, this transaction is causing a few trouble. So 1.666 milliseconds is taking for this specific transaction to be completed. Now I want to drill down into the transaction to understand where exactly the issue is. So I'm clicking on this transaction. So here I can see the traces that is leading this specific transaction to have 1.59 of the milliseconds. So we can drill down into this traces tab. So before that, if you scroll down, you can able to see the response time broken by the components. By hovering to a specific time frame, we can see what are all the calls that were made. So this, to complete this specific transaction, this application requires HTTP call, the app code execution, the JDBC call, and the overall response time is around 11,230 milliseconds. And you can see the components that has been associated between the application server. HTTP call and the app code execution is enough in order to complete this transaction. And what is the request throughput, data throughput metrics. So these are all some primary metrics you can able to see. Now I want to check under the stack level trace, under the code level stage. So in order to do that, you can check this specific time frame. These are all the time frame that was associated. I am just sorting out the average time frame, average response time, and this specific trace is having a high response time. So I want to drill down into the code level stack. If I click on that, here I can see the complete trace details. So these are all the method calls that has been captured. So in order to complete this specific transaction, we need 4 method. Your application requires 4 method call and 1 SQL call to make the transaction. And it is clear that this is the specific transaction method call that is leading to the leading this transaction to have 1.69 of response time. So now you can take this specific full page as a screenshot or a visible part, and you need to share this information with your application team. So your application team will work with your work in order to make this specific method calls optimized for better performance. and what are all the attributes that has been requested, and what are the SQL statement. As I mentioned, there is one SQL call required, and this is a specific SQL call that is required for your application. If there are any external call that is associated, and the external call is going to be the database over here, and this is a JDBC external call that has been identified. And if there are any exceptions that has been thrown, we can identify that. So in this transaction, we can see on this specific timestamp, there is one exception that has been identified. We can click on the exception class to understand the stack trace over here. If there any other transaction that has been performed, we can see the complete transactions along with the traces details over here. So from the overview, we can see the top 5 transactions that is having high response time. Now we are getting into the transaction to identify the code level stack by getting into the traces. From the transaction to traces, we can able to identify the method calls. This is the one end. And the other end, let's say there are some databases call that is having taking database queries or many slow queries that has been identified in your application, which is leading a high response time. So under the database tab, we will capture all the select, update, insert, and delete queries. So we can able to drill down. For example, I'm just sorting out for the average response time. So this specific insert card query is having a 3.0.33 millisecond, which is a good response time, but still in the production environment, we might find some database operation queries which may have high response time. If you want to drill down into the database operation, just clicking on that, we can drill down into the transaction, and we can able to see what is the transaction that is being used in order to complete in order to make use of this specific database query. So this database query is being insert query is being executed under this specific transaction. So likewise, and what is the SQL time that is taken? So if the database query is taking more time in any specific transaction identified over here, so with the help of our DBA team, we can able to optimize the specific transaction. And the next is the JVM. So under the JVM tab, we can able to see the complete JVM details over here. Let me show you. Okay, so JVM. So using the JVM tab, we can able to see the complete Java details, or what is the heap details that is being collected and everything. If you see the summary in the JVM tab, you can see what is the CPU usage that is being used by your Java application, what is the heap memory usage, or runtime memory usage, JIT time, runtime, and the classes, how many classes are getting loaded and unloaded in the last 30 minutes. So the heap memory, non-heap memory, all these metrics related to the Java has been completely captured and available for monitoring. And under the exceptions tab, we can able to find any exception that has been captured. So as you can see, what are the top exceptions and what is the count, how many times it has been captured. If there are any error codes, if there are any 500 error, 5404 error has been captured, we can able to see how many times it has been captured. So likewise, the complete errors, exception splits, all from all the transactions, what is the recent exception traces has been found in the transaction, recent 5. All these details can be captured using the exceptions. So by capturing these details, working with our application team to optimizing and improving the application performance one by one on the each transaction level, we can make sure our end users can have the better application performance. And this is a service map that I spoken about. And if you look at this specific application, has been completely associated with these components. So in order to playing a blame game within the internal team, so after an outage, we can come here and directly identify which specific component has been broken. Let's assume this specific component is a database, and if it is affected, it will be turned into a red. So we can directly found that, okay, this specific component has been broken, due to which the application outage has been occurred. Same likewise, using the service map feature, at a glance, you can able to monitor the components associated within your application. And we do have a similar feature called the app parameters. So using this app parameters, you can able to monitor the complete performance of your custom parameters. If you have any custom parameters to be added, you can directly add it, the minimum and average and the sum of the performance with the percentile data. You can able to monitor that. Similar to that, we have the threat profiling. So threat profiling is nothing but, so based on the we can initiate a threat profiling for the 15 minutes of the 15 minutes delay or 15 minutes time frame. So in this time frame, it will collect all the threads. With the help of this thread profile, we can able to understand what are all the threads that is causing the high consumption and the high heat memory. And yeah, so based on that, we can able to see the complete view. And as I mentioned about the RAM analytics feature, so this is a RAM analytics feature that I mentioned. So using this RAM analytics, we can able to compare and correlate the complete front-end performance. And you are going to see this complete demonstration of the RAM analytics in the upcoming digital experience wanting session. And apart from that, so you can see the complete front-end performance of your application using the APDEX score, response time, page views, JavaScript errors, and the geographical data. And this also can be found under the Home tab as well. So under the Home tab, we do have something called the application dashboard. So this is application dashboard, as I mentioned. So in this application dashboard, you can able to see the complete APDEX score of the front-end level, of the backend. This is a APM. It's a backend level. This is a real user monitoring, is a front end level. So by having this type of dashboard within your application team, you can able to verify and understand how it exactly performance behaves for your end users, and doing a continuous improvement. It will be helpful for your application team to avoid any kind of outages in your application. And apart from that, we have the reporting section. So in the reporting section, so we can able to fetch the reports of your application, complete application. What is the HTTP response, what is the threat response, what is the availability, health report, and custom attributes like a 5xx attribute, active connections. All this can be taken as a report as well. And this is how the complete APM insight feature works in the applications manager. So that's it. And now let's quickly get into have a quick recap. So along with that, if you would, I hope this specific APM Insight quick demo might helpful. If you feel like you would like to have a detailed, personalized demo on this APM Insight feature to see how this works on your environment, kindly hit the poll displayed on the screen. Our team will reach you out soon in order to schedule a personalized demo for this specific feature. Now let's have a quick recap on today's session. So in the first part, we discussed how to track application performance using APDEX score. Next, we explored how to identify the problems in the application code. In the third segment, we saw how to track transactions from one application to another and debug the issues. In the last part, we encircled identifying problems in the code level stack and concluded by discussing how the service map feature helps in identifying the problems. Thank you, everyone. We appreciate your time and participation. Have a great day.